Hi, welcome to this video which will talk a little bit about the side-side-side similarity theorem. That's a theorem that we use for similar figures, and it's a way to show or prove that two figures, in the case that we're looking at right now, two triangles, are similar. So similar figures have two properties. If you want to write this down in your notes, it's not a bad idea. If two figures are said to be similar, their corresponding angles are congruent, which also means equal. In the world of geometry, we tend to use the word congruent quite often. And the symbol for congruent, if you haven't seen it, is that. It just means that the shapes and size are the same. Also, if we have similar figures, the corresponding sides are proportional. I'm going to show you how to determine that in just a minute. Proportions are just basically, they involve fractions, and we're going to take that a step further. Fractions also mean that you can divide the numbers, and that's how we're going to check proportionality. I also have the word corresponding. The best way, so if you didn't understand what the word corresponding meant in that little definition, I would say matching. If you have done any work in geometry and you've done congruent figures, you should be a pro by now at at corresponding parts. So let's just start with the problem below. Our instructions say to determine if the similarity statement is true. This here is a similarity statement. And the order of the letters is very important. So if these two figures are similar, based on this statement here, I forgot to say this little symbol is called similar. That is the notation that we use so that we don't have to write out the word. Mathematicians do not like to write out words, so they try to come up with symbols. So if triangle TUV is similar to triangle ABC, the corresponding parts are going to be shown by the order of the letters. So T is the first letter in the first triangle, that's here, and it would correspond or match up with angle A in the other triangle. So if they are similar, those will be congruent angles. We don't know that yet, we're trying to prove that. Just because this is our first problem together, let's look at the other corresponding parts. Angle U, which is the second letter, would match up with the second letter, which is B. So U would correspond with B, which means if they're similar, those two angles will be congruent or equal to each other. And then finally, we do have the third letter in each of those. We have V would correspond or match up to C, so V and C. So if we do find out that these are proportional or similar figures, those angles are going to be congruent to each other as well. So here's what we're going to do. The side for similarity theorem says that the proportions or the ratios of the three corresponding sides has to be equal. Well, that's a mouthful, especially if you're out of practice in math. So what is a ratio? It's a fraction. All right, so let's look at our top triangle and find the smallest side. 16 is our smallest side. And we're going to divide that by the smallest side in our other triangle, which is 52. So grab a calculator. It's going to be a decimal. So if we do 16 divided by 52, we get 0.307. It goes on actually longer than that, but I'm just going to carry it 3 places. So let's look at our triangle ABC and find the medium side. And we're going to do the same thing. We're going to check medium divided by medium and large divided by large. So our medium side of triangle ABC is 20. And when we go down to triangle TUV, our medium side is 65. Again, grab your calculator, 20 divided by 65. That also comes out to 0.307 with a bunch of other numbers. So far, we're good. These match. So far, these two sets of sides are proportional because they equal. This equals that. For it to be a totally similar figure, we need to check all sides. So we need to check all 3 pairs. If we had a quadrilateral that we were checking for similarity, we would need to check all 4 pairs. If we had a hexagon that we were checking similarity, we would need to check all 6 pairs. Okay, so let's carry that out. Our biggest side on triangle ABC is 28. And our biggest side on triangle TUV is 91. Again, grab your calculator. 28 divided by 91 is also 0.307. So we have proven that because all 3 of these are equal to each other, the ratios are equal, then the sides are indeed proportional. So we can say because we've checked all 3 sides, we're using the side theorem for triangles, and we can say that this is true. All right, let's take a look at another one. Let me switch colors. Okay, so again, here's our similarity statement we need to check. So let's just start off by checking the ratios of the sides. So on our triangle RPQ, our smallest side is 24. And we need to divide that by the smallest side on triangle STU, which is 7. So if we do 24 divided by 7, we get 3.428, I'll say for now. It goes on to infinity. And now let's check our medium sides. For triangle RPQ, our medium side is 42. And we're going to divide that by the medium measured side on triangle STU, which is 14. And 42 divided by 14 equals, aha, we can stop. All right, 42 divided by 14 is 3. The first ratio that we solved, we got 3.428. These are not equal. We don't need to check all three sides. We're done. We can say that this is false. These two triangles are not similar to each other. They look it, right? Just by your eyeballs, they're like, oh, they look pretty. They look like they measure up. Perfect. But it's the math behind them. These are the ways that you prove that. All right, let's check this triangle here. Again, here's our similarity statement. Triangle RST, is it similar to triangle SBA? So we're going to follow the same thing. Our top triangle, the smallest side is 11. We're going to divide that by the smallest side in the lower triangle. And again, notice how they're kind of flipped around. The orientation is different. Our smallest side here is 23. Grab a calculator, and we get 0.478. Go to the medium sides, that's 12. We're going to divide that by 25, which is the medium measured side in our lower triangle. 12 divided by 25. We're getting, 0.48 on that. And again, I can stop, okay? For 0.478 is not equal to 0.48. And sure, if I rounded this up, it would be similar. But it's not going to happen. They have to be exactly the same. Plus, as I just kind of glance at the triangles, the sides that we haven't checked, I can see 18 and 36, and I believe that that's just going to be 0.5. Yeah. So you don't have to check all three sides once you get two that are not equal. The ratios are not equal. All right, let's move on to our last problem. This one might be a good one where you can hit pause, try the problem yourself, and then come back and hit play and see if you got the right answer. So the similarity statement that we're trying to determine if it's true is triangle DEF. Is that similar to triangle TSR? So on my top triangle, my smallest side is 35. I'm going to divide that by 7, and I know that that is going to be 5. Back at the upper triangle, we're going to take our medium-sized side, which is 60, divided by our medium-sized side, which is 12, and 60 divided by 12 is also 5. So far, so good. And now we need to go to our last side. Our largest side is 64 in the upper triangle, divided by the largest side in the lower. So it's 64 divided by 13. Oh, nope. We were on such a roll. This is 4.92. All right, so again, is this similarity statement true? It is not true. It is false. There are other ways to prove triangles are similar. One is the side angle side for similarity, and also the angle, and there's a couple that also involve right triangles. But those will be other videos, so you can search for those. But I hope that this helped for side similarity. Thank you.